All right. So this example 6 is also very interesting. It says find the exact value of this expression. So here, how do we answer this type of question? This is sine outside, and you have inverse function inside. So what we're going to do is we're going to make some substitution, like you will let your alpha to be tan inverse of minus 3 over 4, right? And at the same time, we can make beta to be cosine inverse of 12 over 13, right? So it means that this will just become what? It means it becomes sine of what? Alpha plus beta. Can you see that? Just by making these two substitution. And this means that what? This is going to be sine alpha cosine beta, right? Plus cosine of alpha sine of beta. This is what it is, yes? So now let's come back here. If you look at the substitution, what is this? This means that tan alpha, if I take tan of both sides, so tan alpha will be minus 3 over 4, right? And remember, this is tan inverse. Tan inverse can only be found in the first or in the fourth quadrant because of the range. Now, tan is negative. Tan can only be negative in the second or in the what? Or in the fourth quadrant, yes? Yes. So this tells us that what? That alpha has to be in the what? In the fourth quadrant, because that is what is common, right? Look at it, the fourth quadrant. So let's go to the fourth quadrant and draw our alpha. So alpha is in the fourth quadrant. And alpha, tan alpha is minus 3 over 4. So this is going to be 3. And the opposite over adjacent. So this is 4. So the 3 is actually negative. And then we can get the other value. And this hypotenuse is just going to be 5, right? Okay. Then let's come back here. Let's go to beta now. For beta, this is cosine inverse, right? But we know that what? Cosine inverse could only be in the first or in the second quadrant because of the range, right? So this, if you take cosine of both sides, it means that cosine beta is going to be what? 12 over what? 13. But this means that cosine is positive, so it's either in the first or in the fourth quadrant, right? And now you will see that what is the common quadrant here? The common quadrant here is quadrant number 1. So this is number 1. So it means that we're going to be in quadrant number 1. So let's draw it again. So we have quadrant 1. We can draw it the same with this, but let's just draw it separately. And this is going to be beta, which is so cosine is adjacent. So this is 12, and this is what? 13 adjacent over this, right? Then we can get the opposite. And what is the opposite? The opposite is nothing but 5. Using Pythagoras theorem, you will get this to be 5, which is the square of 13 minus the square of 12, right? And that will be 5. So here, let me just write it. This is what we're using. If you want to get this, would just be the square of 12, 13 minus the square of 12, all of it inside roots. And this will be 169 minus 144, 144, right? and this will just be 25. Root of 25 is 5. So here it's 5. Okay. So now we're back here. Remember, this is where we, after the substitution, we're back. So to finish, it means we need to get what is sine alpha. So to get sine alpha, we have to come back here. If you come back to this, you will see that sine alpha from here is what? The sine is -3 over what? Over 5. So we come back here, we add -3 over 5, which is sine, then multiply by cosine beta. For cosine beta, you have to come here. You will see that from here, cosine beta is, we already have it here, 12 over 13. So this is 12 over 13 plus cosine alpha. What is cosine alpha? Cosine alpha, we have to come here. You can see cosine alpha is adjacent, right, over hypotenuse. So this is 4 over 5. So we have 4 over 5. Then sine beta. Sine beta is what? Sine beta is opposites, which is 5 over what? Over 13. Now, this is going to be minus 30 what? 36 plus 20 all over 65, right? And this is nothing but minus 16 over what? Over 65. All right. So this is the final answer for this expression, minus 16 over 65. All right, so similarly here, we'll do the same thing. We will let alpha to be sine inverse of what? 4 over 5. And we will let beta to be cosine inverse of what? 2 over 3. Now, it means the problem will reduce to what? Cosine alpha minus beta. And this is nothing but cosine alpha, cosine beta, plus what? Sine alpha, sine what? Sine beta, right? So let's play with this one now. What is alpha? This means that sine alpha is equals to 4 over 5. But we know that sine inverse is either in the first or in the fourth quadrant. And sine is positive either in the first or in the what? In the second quadrant. So we take the quadrant that is common, which turns out to be quadrant number 1. So it means we will be in quadrant number 1, something like this. So in quadrant number 1, you have alpha. The sine is already 4 over what? Over hypotenuse, which is 5. And definitely this is just going to be, the adjacent is going to be 3, right? Similarly here, this is cosine inverse, which is either in the first or in the second quadrant, right? So cosine of beta is what? 2 out of 3 over 3. So this is positive. It's only possible in the first or in the fourth quadrant. So it means that this also, what is the common quadrant here? The common quadrant is still quadrant number 1. Okay, so we're going to have also our beta in the first quadrant. Right? So cosine beta is what is adjacent over hypotenuse. So it means the adjacent is going to be 2. Hypotenuse is 3. And then we can get what is the opposite. So the opposite is going to be the root of what? 9 minus 4 So that is going to be the root of 5 here. All right, so let's get back here now. Now cosine alpha, what is cosine alpha? Is 2 over 3. No, we don't know yet. So for cosine alpha, we have to come back here. You see cosine alpha is going to be 3 over what? 3 over 5. Yeah. So this is going to be 3 over 5 multiplied by cosine beta. Cosine beta, we already know we have it here, which is 2 out of 3 over 3 plus then sine alpha. Sine alpha is this, which is 4 over 5. Then sine beta. Where is sine beta? If you want to know sine beta, we have to come back here. What is sine beta from here? It's going to be root 5 over what? Because it's opposites over hypotenuse. So this is root 5 all over what? Over 3. Right. So this will give us 6 over 15 plus 4 root 5 over 15, which we can add as this one over 15. 4. Okay, so thank you. The next we will see, okay, let's just combine these two as well. I think we can combine this in one. So example 7. Example 7 is when you have expression involving what? Co-function identity. Okay, now look at this one here. He said evaluate each expression. This is sine 27 cosine of what? 57. So what we can do here, we can use the co-function identities, right? We can use the co-function identities. And how do we do that? Here we can write this as sine 27 cosine of what? 57, right? But this, you can see it's sine cosine, so definitely we need sine and cosine. It's going to be more likely the sine function. So, but this, we can change this one. Here you have to watch that they are not exactly the same. For example, this is 27, but here you can see that this is not 27, this is 63. Here we can see that this is 57 and this is what? This is 33. So let's change the left-hand side, or let's say the right-hand side. When I say the right-hand side, I mean this part. This is sine 63. We can write it in terms of cosine. This will become cosine 90 minus what? 63. And also this cosine, we can change it to be sine 90 minus what? Minus 33. So here we'll have sine 27 cosine of what? 57. Now this is going to be cosine of what? 90 minus this will give us 27. And this will give us sine of what? 57. Okay. Now this makes sense now. You see that now the angles are the same. So we can apply our formula. You see this is 27. This is 27. And this is what? Is 57. And this is also 57. All right. But we can still see that it's a combination of sine and cosine. So definitely this will go with the sine, not the cosine, right? So this is nothing but sine of what? 27 degree minus cosine of what? 57 degree. See that? And if you expand this, you will get back there because you have sine 27 cosine 50. then what? Then cosine 27, then sine 57. So this becomes sine 27. No, there's no cosine inside again. This is just 57 here. So what is 27 minus this? This is minus 30, right? But we know the sign is odd, so this is minus tan sine 30, and this is just minus half. All right, then for this one, the B question, it's what? Here, we have to use the same thing. This is, we have to try to write, this is tan 70 plus cotan 10 is the same thing as tan 90 minus 10, right? Over, this is 1 minus tan 80, and then this is tan also 90 minus 20. So this becomes tan 70 plus tan 80 over 1 minus tan 80 and tan 70. So if you remember the formula, you will see that this is nothing but what? Tan of what? 70 degree plus 80 degree. Remember, recall that if you have tan alpha plus beta is nothing but tan alpha plus tan what? Beta over 1 minus tan alpha tan beta. All right, so you have tan 70 plus 80, and this is nothing but what? Tan of 150 degree. And what is tan 150 degree? Tan 150 degree is simply what? $150 degree is in which quadrant? Remember, is in the third, is in the second quadrant, right? Yes, is in the second quadrant. And since in the second quadrant, this will be minus tan. We're using reference angle now. So this is just like minus tan 180 minus 150, right? And this is just going to be minus tan of what? 30. And this is nothing but minus tan 30 is 1 over root 3, right? So this is the answer. All right, so this is the end for this section. This video, we'll still have 2 more videos to go, and 7.2. So watch out for the next video, which will be how to write a linear combination of sine and cosine in terms of only sine. If you like this video, don't forget to like this video and subscribe if you're not yet subscribed, and also share with your friends. Thank you for watching.